All right, so in this lesson, I'm going to show you how to very easily find the equation of a sine graph. The steps are, you want to add the equation of the curve to the graph first, okay? Then you want to pick a point on the equation of the curve that crosses your graph, and then you want to find the amplitude, which is the stretch or compression. And we're going to write it in this form here. So the first thing you want to do is add the axes of the curve. And remember that equation is exactly between your max and your min. So our max is 2, our min is -4. The number between those two, if you add them together and divide by 2, you're going to get y equals -1. And so that's your axes of the curve. So that's always the first step. And then you want to take a look and see where your axes of the curve crosses the actual equation. So I can see it crosses here, and I can see that it crosses there. So we can use any of those 2 points to write our equation. Now, if I had a bigger graph and I continued my curve, then I would have, like if it continued up here, then I'd have another point here, and then also down here, right? This goes on forever from both sides. So any of those points can be used to write the equation. All right, so let's use, well, why don't we use this one as our example? I'm going to use that point. That point is 90, right, 90 degrees, and -1. So what that means is normally that point would be right here, like if you, right here, like if you think about what a sine curve looks like, right, it looks something like this. Right? So that point would normally be here, but now it's been moved over 90 to the right and down -1. So that's going to be my horizontal translation and my vertical translation. So moving to the right 90 is normally written in the bracket as x minus 90 inside the bracket, right? It's written in the with the opposite sign. And I said we're moving down -1, so your C is going to be -1. The A, that's the amplitude in the front. The way you find the amplitude is you look at your axes of curve and then you go up to your maximum and you see what that distance is, or you can go from your axes of curve down to your minimum. It's going to be the same answer, right? Because your axis of the curve is exactly in between the max and the min. So in this case, it happens to be 3. I think I have a spot for that here. Yeah, my amplitude is 3. And so that's going to be the A in front of the sine. So we have 3 sine. And then you also want to see if you have a horizontal compression or a stretch, and that's the K. And the way you find that is you want to divide 360 by the period. And in this case, if you look at our curve, it takes 360 degrees for it to repeat. So you can pick a point on the curve anywhere. So if you start down here, for example, you follow the curve, so -180, and you see how long it takes before it starts to repeat again. So once it gets to this point here, then it goes back up and it's starting to repeat. And so how long did it take for me to get from my starting point to the end point? Well, it was -180 to +180, and that is 360 degrees. So my period is 360. So our K is 360 divided by 360, which is 1. So if you want, you can put the 1 in there or you can leave it out. Sometimes there's a horizontal stretch or compression where the period is different, and then that affects the K that goes in front of the bracket there after the sign. So that's our equation. Our range is R equals Y such that the min and the max, right? So the range is between -4 and 4. Oh, -4 and 2. And then Y is in the real number system. The other thing I forgot to mention is that how do we know if it's a reflection in the x-axis or not? This one happens to have a reflection. This one is going to actually be -3. And the way I know that is because we picked this point here. And normally our graph is at 0, 0, and it goes up to the right, right? Now our graph is going down to the right. Okay, so that's how I know that it's a reflection. Okay, I could have also written this equation. So if you put this into decimals to graph, you can check to see that the graph will look exactly like the one in the picture here. The other way to write this equation would be if I had selected this point here. Okay, so everything would be the same except a couple different things. So the amplitude is still the same, so it's going to be 3 sine. The k is still going to be 1, it's the same period. So you can just leave that one off or put it in there if you want. Inside the bracket, this point here is negative 90, negative 1. All right, so in the bracket, we will write it as x plus 90 instead of minus. And this point here, going to the right, it's going up to the right. So that means the 3 in the front is going to be positive. Okay, and it's negative 1 as the y coordinate of the point that we picked, so that's still going to be minus 1. So if you put this into Desmos, and the first equation that I wrote out, these are going to be exactly the same, and it should look like our picture. So a couple different ways of writing the exact same, for the same graph, but it could be written in two different ways. I think that's it on here. Oh, the phase shift is just, is it moving right or left, and by how much? So if I was writing these answers for the first equation, then I would say my phase shift is to the right, 90 degrees, okay? Or if I was using the second equation, I would say to the left, 90 degrees. Okay, both answers are correct depending on which equation you're going to write to represent this graph. All right, good luck, and let me know if you need some help.